So a geometric series is the sum of the terms of a geometric sequence. So I've written out what a series could look like here. So the numbers 2, 6, and 18 would be of a geometric sequence with a first term of 2 and a common ratio of 3 because you're multiplying by 3. So we'll be adding those up to make it a geometric series. So just like we did in the previous lesson with arithmetic series. Now to come up with the general formula, this is going to involve a little more trickery than the last one. So I've written out, again, sum of the first n terms, same notation used. First term is a, and then the next term is a times r. And the next term is a times r squared, because we're multiplying by r again. And then so on, until your final term, so term n, is a times r to the power of n minus 1. Now, what this second equation is, I've taken the first equation and I've multiplied everything by r. So you see that this first term a is multiplied by r. This second term ar squared, ar is multiplied by r to give you ar squared, and so on and so on. Now the final term ar to the power of n minus 1, if you multiply that by r, you're adding 1 to the exponent, so the exponent is now just n. So I'm going to be using these two equations to come up with our general formula. Now, again, this is where a little bit of trickery comes in. I'm actually going to swap the location of these two equations, like so. And what I'm going to do is I'm going to subtract the equations this time to come up with my general formula. So on the left-hand side, I'll have r times the sum of the first n terms minus the sum of the first n terms. There's nothing I can do with that right now. So let's see what happens when I subtract these equations. Now, right now, there is no a term in this line right here. So I'm going to be subtracting a, and there's not going to be any like terms with that because everything here is at least multiplied by r. But now, if I have AR and I'm subtracting by AR, they cancel out. If I have AR squared and I'm subtracting AR squared, they cancel out. Okay, so nothing was there on top to cancel out the A. That's why I have negative A here. But things are going to keep canceling out. Now here we have AR to the power of n minus 1. We'll cancel out that one on the bottom. So we're left with one more term. We're left with plus AR to the power of n on top. Alright, so this is what I have, and again I want a formula for the sum. So what I can do is everyone's favorite factoring. So sum of the first n terms, factor that out. I'd be left with r minus 1. Now over here I can actually factor out an a, and just changing the order of these, I'll have r to the power of n minus 1. So again, I want to isolate the sum, so I can divide both sides by r minus 1, and this gives us our general formula. So the sum of the first n terms of a geometric series is equal to a times r to the power of n minus 1, and then divided by r minus 1. Now it's important to note at this point that the r value cannot be 1 because that would give us a denominator of 0, and as we know, that is not allowed. Alright, so this is the formula that we can use, and this is the only formula for a geometric series. There aren't two, as in with arithmetic. So an easy example here, we want to find the sum of the following for 8 terms. So we're finding the sum of the first 8 terms. Now we have to look at this and determine, is it arithmetic or geometric? So it is geometric because we're multiplying by 3 for our terms. So that gives us a common ratio of 3. So I can use this formula right here. What you can also tell is that the first term is 2. And again, my n value is 8 because that's the number of terms. So just following along with the formula here, we have 2 times, then we have 3 to the power of 8, and then subtract 1. It's very important to note, and this is a common mistake, is that people will subtract 1 from the exponent, but it's actually 3 to the power of 8, and then subtract 1. Okay, so be careful with that. And then we have r minus 1 in the denominator, so 3 minus 1. I don't mind if you would just put 2 in that case there. So just punch that into your calculator and you will get that the sum of the first 8 terms is 6,560. All right, so no need to determine between two equations here. There's only one for the geometric series, so make sure you remember that.